So welcome to this class where we will be able to learn about this insertion sort. So insertion sort is a sorting technique. Sorting is arranging the elements in ascending or descending order. As we already have done this in the other video, detailed one, we will see the example of insertion sort. So what's the example here? You can see uh, as I've given you example earlier also, this is just like if we have a deck of cards facing downwards and all are unsorted and we have to pick cards one by one. Whenever we pick a first card, let's say first card is 3, first card is 4, let's say, and first card will always be sorted. We need not to sort the first card. Okay, so this one is an example of practical example of insertion sort. Now we will take the second card out of deck of unsorted cards. These all are deck of unsorted cards. Okay, so we want to place it this card at its own position. So how can we do that? We'll compare it with the previous element. If it is smaller, then we will move this heavier element forward and this smaller element on the left side. So this in this way, this list will be sorted and this whole list will be unsorted. The colored list is sorted and uncolored list is not sorted. Okay, so red and green are sorted. Now we'll pick a next iteration we'll pick a next card and we'll compare it with the each element with 4, with 3, and if we want to find actually its right position, that is there after 3. So we'll move the heavier elements forward. So we can see that 4 is at this position, 3 is at this position, and we'll place it 2 here. Now we can see 10. So 10 is greater than this element, so we need not to compare it with the all the other elements because this is a sorted list. If 10 is greater than this element, it will obviously be greater than all the other elements, so we need not to compare it with the other elements. So then we can go on, we can pick the next element, that is 12. So 12 again is greater than 10, so we need not to compare it with all the elements. And then we have 1. So 1 is smaller than 12, so we'll move 12 forward, one step forward, and then we'll compare 1 with 10. 10 is also greater, so 4 is also greater. We'll do the same steps as we did with the 12. So one correct position is before 2, so 2 will be moved here, 3 will be moved here. So this is the sorted list, and this is our next iteration. Then we need to compare all the elements with 5. So we'll compare it with 12, we'll compare it with the 10, and we'll keep on moving the elements which are greater than this element. We'll move that elements forward, but we have found the right position of 5, that is after 4. So we'll place 5 after 4, and in this way we can accomplish our sorting. So this technique is called insertion sort. So let's see one more example of insertion sort that is given here on your screen. That is the elements are 25, 17, 31, 3 and 2. Let me run this one. This one will compare the first two elements, and if this is smaller, then we'll exchange these two elements. And in second iteration, we'll compare with these elements because this is we'll compare with the all elements that are before this 31. So we are comparing. If the elements are smaller, then we'll need not to do anything. So we can see on the screen that 13 is being compared with this element, that is 0, and if this one is smaller, then we'll replace this one. This is another technique that can also be used. So this is last element comparing A4 with this, and we have found the right position of these two. So this is how insertion sort is done. Now we shall see its program in C++. So let's start this insertion sort. So first of all, we can write a comment or something like that. This one is a insertion sort. So this one is an insertion sort, and we can write its main function. And in compound statements, I'll declare an array of any size, and I can give the elements like these are actually unsorted list of elements. You can take any elements and try it on your own. And after that, I'll calculate the size of array. So I need to put brackets here. This is name of my array. And if I'll divide it with any one element size, then this will return me the number of elements, that is n. And now I need to call a function insertion sort, or I can write it inside the main function. That is not a problem. And I'll create two functions actually, to print an array, to print a sorted array, and to do the insertion sort. So I'll call two functions here. After that, I need to write get ch, and I will write clear screen here. Okay, for get ch and clear screen, we need two header files that are iostream.h and conio.h. Okay, so now let's see a function. We'll create a function where we'll do the insertion sort. So we'll write void and insertion sort. This is the name of the function, and I'll pass the array. I'll take the array as an argument and one for the size of the array. So we can call this function here in the main function. So I'll write insertion sort and pass the array and then the size of the array. So we can call the function here. So before calling, we need to specify its algorithm. So what will be the algorithm here? Here we need two variables, I, and then we need a variable key, and then we need a variable j. Okay, so if we are starting, our array is index is starting from 0, so we'll start this loop from 1. And if we are starting our array index from 1, then this loop will start from 2. So that's why we have written I equals to 1, I less than equals to n, any number, the number of elements, and I plus plus. This is how for loop works. And inside for loop, we are going to assign key variable, or we can take here as this one as j and this one also as j, like we did in the algorithm of insertion sort, and we have assigned ARR of j to key element. Okay, then there is one more step, that is I equals to j minus 1. Okay, now in order to inside this for loop, we'll take one more loop, that is while loop, that we have discussed already. Then I should be greater than or equals to 0 here, because we are starting it from 0, and operator will be used to specify that both these conditions should be true. Okay, so the second condition, either the list should end, or or the element should be greater than the key element. Then only we will do this step, the following steps. What are those following steps? We'll copy, we will copy ARR in ARR of I plus 1. We will copy ARR of I, and then we'll write I equals to I minus 1 to go for the previous element, Once we are done with this, we need ARR of I plus 1, and we'll put key element inside it. So key element will be inserted here. This is our function for insertion sort. Now let's see, this is function for insertion sort, or we can do like this. This one is inside this function, so proper indentation is being done here. This one is inside this for loop, while loop. Okay, so this is it, this is our program, and we need to call insertion sort here. After calling, we need to print the array again. Then only we will be able to know that our arrays are sorted or not. So we will print our array. We'll use any function, like we can create a function here, print ARR, and we'll pass the arguments array and the size of the array, and we can create one more function here, or you can do it here only in the main function. That is your choice. So this is our print ARR function, which we have called it in the main function. So and after we need to write, after this we need to write its definition. So how can we print an array? We'll simply take I, and then we'll take a for loop. Inside for loop, I'll start with 0, and I'll write I less than n, I less than n, and then we will write here I plus plus, and we'll print the array. Simply we will print the array. How to print the array? We'll write cout ARR of I, and I will eventually get printed. We'll put a space in each element, and then We'll also take a new line after this. So this is end L. End L is for new line. End line. Let's see if it works or not. We are done with our program. So let's see if it works or not. We can see that this program is not saved. Let's save it first. So I'll name it as INS, that is insertion sort.cpp, and this program is saved. Let's see if there is an error. There is no error in it, and let's run this one. So we can see our elements are sorted. So elements are 5, 6, 11, 12, and 13. So this is how insertion sort is done. Thank you.